And I would like to start the session with some of the questions that were left unanswered. I would be happy to ask the questions for you, but feel free if you want to shout them yourself.
Maybe before we start this, quickly explain for people who are new what will happen now in this panel discussion. So the idea is that all of the speakers from the previous session are invited now to kind of an open panel discussion, and there will be kind of primarily targeted towards those papers and also like between those speakers, some questions that, as Ilona said, have been left unanswered. So this is kind of the idea of this panel discussion now, to specifically address those papers.
Yeah, thank you, Alex. So I'll start with a question that Felipe had. That is for Antonio, the SMT paper. How difficult would it be to extend to multi-pages? Seems that this is the same kind of issue than going from one system to the other, which I added a bit more to that question, and just going beyond piano forms.
Okay, so I will start with the last question. Extending to other music textures, as long as we have the data to train the model, it wouldn't be very difficult if we train the model on single notation, like only on that specific notation. Combining all of the music textures into a single model, it is more difficult, because the syntax of the language encoding plays a significant role here. And also we are delving into what it would be like an universal OMR, which is more challenging, that it can be seen from just the first perspective. I think that extending to other notations, if we keep just extending to the textures, if we keep the model focused on that texture, it's not that difficult as long as we have the data, but combining all of them, it's more challenging. And I think it's research that has to be done. And extending to multi-pages, maybe it would require a change. Well, it can be, we can just concatenate all of the images or propose them as a batch, for example, but there is no research into that. And also, I believe that maybe we have to do some changes into the architecture itself. We maybe also have to do some image compression, also maybe using pre-trained models for identifying images, change things in the positional encoding as they are doing in the visual question answering field. I think that's more challenging to feature, also depending on the number of pages we want to process.
Thank you. I would maybe ask another tangential question to that one, and is how well does it perform to music that is not from the same era, I guess? How much does the model learn the genre or the era?
Well, actually, that's very interesting, because that's a limitation on the synthetic data. We are training on 18th century music excerpts. So if you jump to other eras, it depends also on how many data you have for fine-tuning, and usually the language model adapts well with few samples, but definitely that plays a critical role on the general ability of the model. And I guess I can say that, since if you have the data to do so, it is not, well, the model adapts really well, but if you don't have, you are tied to the synthetic domain. So also that plays also a significant role into that.
Thank you. I'll continue with the next questions. Daniel Mayer asked about the spatial resolution of the patch size of the transformer.
Since we are using a ComNext in this case, which patchifies or pre-patchifies the image, it is a 4x4 patches in the implementation we have. The ComNext first performs 4x4 patches and then does all the processing and reduction of the image.
So right. This is 4x4 pixels in the image, or
yes,
4x4 patches for the entire image?
Yeah, but bear in mind that the ComNext uses a first stem, such in the Vision transformer and in the Swing transformer, to divide into patches the image. Although it doesn't do it straight away, it does it with a convolutional network on the full image. So when we perform the flattening of the image to feed it into the decoder, it is patches composed of 4 pixels, 4x4 patches.
So, but then there are like extremely many patches, right? If you have a big resolution image.
Well, that's why the ComNext indeed does the image reduction in this side. But if in other experiments, we saw that if you exceeded the 16th by 16th reduction, you will get a worse performance in transcription.
Yeah.
The next question is from Bertrand. Did you change something in the original DAN architecture to build the SMT?
Well, if we refer to the original DAN architecture, like building an autoregressive transformer in such of the way of doing on some other works that have been done in HDR and such, like the core, it is the same, but of course the feature structure is a different network. It is a ComNext, which turned out to be better for music recognition. And also the DAN implements some masking techniques on the decoder. It just gets into, I think, the 100 characters. We suppress that because we found out that, especially in the Harman-Kern notation, the beginning context, it is very relevant, and the language model needs that context, although it is very far away from the actual prediction. So the core architecture, well, it's difficult to be changed because it's a translation model that all of the works have evolved from it. But in the specificities, there are some changes that are adapted to the music domain.
Thank you very much. And now, unless someone else has any question, I'd like to move to another point. All right. So I just wanted to move into the work using graph neural networks. And I just wanted maybe to include more people in that discussion. And how do we see the future of using GNNs into OMR, and just, yeah, especially with Alex and Gregor, who've done some work on it. Do you think there is any future of using the graphical representation and the GNNs in OMR?
Sorry. For the use of the graphical representation, I cannot really state, first of all, because we haven't done this last step of going from the graph to the music. But one thing that is certain is that there are multiple definition of music notation graph, like how objects are supposed to be connected, what objects are supposed to be connected, etc., etc. So this would be maybe a first step in the future to uniform the music notation graph, to know what we really aim for, and then how to go to the music should not be that a big challenge, even if, I mean, we cannot really state it. And for the graph neural network, the thing is that it might not be the best tool for that, for multiple reasons. Like, first of all, what we've tried shows some shortcomings, like it's difficult to train. And also, it's maybe not the best tool in that, because what we are doing is not exactly a link prediction, which usually which graph neural network are good for. But what we're doing is it's closer to what we called graph inference, because we don't have information on the edges at first. That's why we use the KNN. We build this information from scratch, from observation. But there is a new field of research called latent graph inference, where the goal is to tackle this problem of not having an adjacency matrix to describe a graph or something like that, and use all the techniques to obtain these graphs. But those methods, we haven't tried them, but it might be like something that is close to graph neural network, but more suited for this task in OMR. So GNN on their own, I don't know, but I would not say that it's the golden tool for that.
Does anyone have anything else to add? Yuri?
Interesting. I
Oh,
can at least tell you that there is more graph data coming. So if and I know that Musia++ doesn't properly implement the precedence edges. So the inference package that's available in Mang to MIDI has like issues, therefore. But the new stuff will have precedence edges. And if we find any sort of time, we will add precedence edges also to Mosimo++, but I don't want to promise that too badly because I'm not sure when we can prioritize that. But I've also recently looked into like GNNs for this, and I found one paper from earlier from Alicante, which were doing some sort of scene graph generation earlier. So do you have any like recollections of how that worked?
I'm not sure to know if you're talking about the same paper I have in mind. It's also from Spain 2022, from Baro, and it's called Music Graph. It's and they also provide a data set. This one or
Yeah, that's no. I this was question more to Jorge and his people
sorry.
because they you guys did something with scene graph generation, right?
Scene graph?
Or something that tried to predict the whole graph.
Yes, but we were using the Muschema plus.
Yeah, but what were your impressions of that? Like, is it a pathway that, in your view, has a good chance of working?
The problem for us was to scale that. I mean, we were able to directly predict graphs for small crops, but scaling any algorithm with graphs leads to MP. Well, I mean, the algorithms are MP by definition. So if you try to scale your problem is it's going to be impossible. And that's my fear working with graphs. At some point you're doing nice things, and when you try to let's use them for full page, then you may be surprised by the complexity. So in our case was something interesting that we wanted to try, but we saw that at least doing direct generating a graph was not going to scale well.
That would have been my next question. Is anyone else in this group working on something similar? Because it would be a really nice way of starting to connect if you see that someone's presenting some sort of work that you're also working on. We're a very small community, so it'd be nice if we do get together when we have the same research.
Jump in just quickly. Vojta mentioned the new Meshcima synthesizer. It's coming your way pretty soon. There's version 0.1.0 already out. 0.2.0 is almost ready, and adding graph annotations to that is just a matter of writing the exporter. So that's also coming soon to all the graph people
who don't show up. Does anyone else have any question?
I have one more related question / note. Gregor, you mentioned that you don't have a graph to, let's say, music XML code that would do the transformation. Have you thought about writing such a thing or not? Because we have plans to do that anyway, so like we might wanna know about each other.
I know it's not planned to do it, but I don't know tools for that. And yeah, but if you want to talk about it, maybe how to do it, maybe we can do it later, like on the technical part.
Yeah, because I feel like one of the drawbacks of graphs is the fact that they aren't interoperable with the other formats. So if you could build this exporter, it would help a lot to bring those models into the mainstream research, I guess.
Yeah, sure. Yeah, the first thing is that the graph, they're all different from all the data set, they all do different. So we should first choose like one format for the graphs and then try to translate it.
Okay, that makes sense. Thanks.
I mean,
All
one
right.
of the questions here to you, Gregor, is whether you want to continue working on this, or whether as part of your finished master thesis, you're saying, okay, this is it, I'm done here.
Before I go too deep into this.
Yeah, the thing is that I don't know, I wouldn't be available like in the coming months, but maybe later. I don't know about your schedule.
Well, thank you. It's really nice to see new people in the community, and they usually do tend to stay, I think. So that's good news. All right, with this, we can close this session right on time.